Hey, what's up, everybody? Today I want to spend some time discussing ionic compounds and what happens when you put most ionic compounds into water. Now, as a very general rule, and of course there are going to be exceptions to this rule, but as a very sort of general rule, when you take an ionic compound and you put it into water, it's going to dissolve. Ionic compounds tend to be, in general, highly soluble when you put them in water. And so to sort of explore this, what does it mean to be soluble? What's going on at the nanoscale? I want to talk a little bit about sodium chloride really quick. So let's say we had solid sodium chloride, all right? So here we have Na, sodium, Cl, sodium chloride, and we're going to have that in the solid phase. Now, again, we're trying to figure out what happens to ionic compounds, such as sodium chloride, for example, when you put them in water. So let's say we took this solid sodium chloride, and let's say we were to drop that into some water. What would happen? Is the sodium chloride going to stay in the solid phase? And the answer is no. In fact, if you were to take solid sodium chloride and put it into water, this is what you would get. You would get some positively charged sodium ions, and they would be in the aqueous phase. And then you would get some negatively charged chloride ions, also in the aqueous phase. So I want to draw some pictures here to sort of explain what's going on at the nanoscale. But basically, what's going to happen is you're going to take this solid sodium chloride and you're going to put it into water, right? And let's just say that this is a sodium ion. Let's say that this is a chloride ion. So initially, when you put that sodium chloride into water, those ions are going to be in pretty close proximity to one another, right? Your sodium ion is going to be pretty much right next to your chloride ion. But after a very short amount of time, and believe me, it won't take very long at all, those ions will actually dissociate from one another. They'll separate from one another. So instead of having sodium in close proximity to some chloride, those ions will dissociate, they'll separate from one another, thus giving us individual sodium ions and chloride ions. So let me draw a picture that sort of illustrates what's going on here. So let's say we had a beaker here, right? And this is going to be before dissociation. All right, so we got a beaker here, and I'm going to put some water into this beaker, right? I'm gonna fill this beaker up with water, right? And this is the top of that water. Now, we're going to have some sodium ions and some chloride ions in here, right? So we're going to take this beaker of water and we're going to put some solid sodium chloride into here. So we're going to have some sodium ions and some chloride ions in here. But they haven't yet dissociated. So if we were to sort of zoom in on the nanoscale with this beaker of water with sodium chloride in it, if we were to sort of zoom in on that beaker to see what's going on at the nanoscale, we would probably see something that looks maybe like this. So we would have sodium ion here. Again, it's positively charged. And it's going to be in very, very close proximity to a negatively charged chloride ion. So this is before dissociation has occurred, right? Before those ions have separated from one another. Now, after some amount of time, and again, it won't take very long at all, those ions will dissociate from one another. So again, we have our beaker here, and we'll call this after dissociation. And our beaker, of course, still has some water in it, right? That water didn't go anywhere. So this is after dissociation, meaning after the ions have separated from one another. So in this case, we're no longer going to have ions directly adjacent to one another in highly close proximity to one another. Instead, we're going to have we're going to have maybe a sodium ion floating around over here. And then we're going to have a chloride ion floating around over here. All right? So just to sort of summarize things up to this point, we had some solid sodium chloride. And we put that solid sodium chloride into a beaker of water. Now, before dissociation has occurred, this sodium chloride is essentially still in the solid phase. It hasn't dissociated from one another, those respective ions. And if we were to look at what's going on at the nanoscale, you'd see that these two ions are still in very close proximity to one another, right? They're essentially still in the solid phase prior to dissociation. Now, after dissociation has occurred, those ions will separate from one another, right? And so we're no longer talking about the solid phase here. No, not the solid phase by any means. Now we're talking about the aqueous, right? The aqueous phase. You see, when you have ions dissociate from one another, when they separate from one another, those ions go from being in the solid phase to being in the aqueous phase. Now, that's really all I want to say for this video. If you want to watch the next video, I'm going to talk more about this. Specifically, we're going to talk about two energies. We're going to talk about a lattice energy, and we're going to talk about hydration energy. And we're going to talk about how you can examine these two energies to see if an ionic compound will dissolve in water. And again, when we're talking about ionic compounds dissolving in water, we're talking about ions dissociating from one another, right? That's to say, initially, we'll have something in the solid phase, for example, where the ions are packed closely to one another. But once those ions go into water, they'll separate, they'll dissociate from one another. And so this is what it's meant when we say that ionic compounds are soluble, that those ions within the crystal lattice, rather, will dissociate from one another. And so that's what it's meant when we say ionic compounds are soluble in water. So again, just feel free to watch the next video. We're going to talk about the two energies that help you determine whether or not an ionic compound dissolves in water, namely lattice energy and hydration energy. So stay tuned and thanks for watching.